Hi, everybody. So in this video, we are going to talk about looking at some word problems and how we can set up a proportion from word problems and then solve. So we're going to look at an example of a ratio and an example of a rate problem. So if you want to go ahead and pause the video and write down the two word problems, all I did was split my page into two sections. We'll work one example up top and then one example at the bottom. So go ahead, pause, write down the two examples. Okay, so in the first example, the word problem says there are 2 dogs for every 6 cats at the shelter. If there are 48 dogs, how many cats are at the shelter? So this is an example of a ratio problem. We are looking at the number of animals at a shelter. So in a ratio, we are comparing things that have the same unit. So dogs and cats are both animals. So what we're going to do is we're going to set up a proportion to figure out how many cats are at the shelter. So I like to kind of use this acronym titled FUNS, F-U-N-S, to help me remember the steps to set up a proportion. What FUNS stands for, the F stands for fractions, the U stands for units, the N stands for numbers, and the S stands for solve. So we're essentially going to set up 2 fractions, put in our units, put in our numbers, and then we are going to solve. And we're going to solve using either the crossroads or the cross multiplication method that we talked about in the previous video. So if I follow these steps, I'm going to set up 2 equivalent fractions. So I'm simply going to put 2 fraction bars and an equal sign in between them. I am setting up 2 things that are equal to each other. And if you remember from the previous video, they basically look like equivalent fractions. So I've set up my fractions. And now I'm going to decide what unit I want to be my numerator and what unit I want to be my denominator. It doesn't matter which unit you put as numerator and denominator. You just have to make sure you're consistent. So our units in this problem are dogs and cats. That's what we're comparing. So I'm going to put cats as my numerator, and I'm going to put dogs as my denominator. So over here on the side, I'm just reminding myself, hey, if it has anything to do with a cat, I'm going to put it as part of the numerators. If it has anything to do with dogs, I'm going to put it as part of the denominator. So I have identified my units and how I'm going to set them up. Now I'm going to plug in the numbers from my problem. So the numbers in my problem, 2 dogs, 6 cats, and they also tell me 48 dogs. And the other piece of information is what I am solving for. So let's plug in the amount or the numbers for cats. So they say that there are 6 cats. So in this first fraction, I'm just going to put 6. And I'm trying to figure out how many cats are like at the shelter in total. So the other piece is where I'm going to put my variable, what I'm solving for. I'm just going to call it X. And next I'm going to look at the dogs. So they say 2 dogs for every 6 cats. So this 2 for dogs needs to go within this same proportion here, because this is kind of the relationship pair they give us, 2 dogs for 6 cats. So it needs to be together on the same ratio. And then if there are 48 dogs, how many cats? So this is where the 48 goes. So essentially 6 cats for every 2 dogs, and we're trying to figure out how many cats if there's 48 dogs. So I kept it consistent, cats with cats, dogs with dogs, and I have put all of my numbers where they're supposed to go. And now I'm going to solve, and I can use either the crossroads or cross multiplication. I always like to check to see if I can do the crossroads method first. So if I look at my numerators and if I look at my denominators, is there an increasing or decreasing factor? That's very obvious. And for me, there is. Going from 2 to 48, I know that I'm multiplying by 24. 2 times 24 makes 48. So if I do 6 times 24, that is going to tell me my value for X, or how many cats are at the shelter. So 6 times 24 is 144. So there are 144 cats at this shelter. That is a bunch of cats. So X is equal to 144. So by setting up two equivalent ratios to each other, and by using the crossroads method of looking at my numerators and denominators, I was able to figure out how many cats were at the shelter. So I set up my two fractions, plugged in my units, plugged in my numbers, and then I solved. Now we're going to look at an example of a rate problem. So the second example is a cheetah can run 10 miles in 320 seconds. How long will it take a cheetah to run 35 miles at a constant rate? So if you kept this rate going, this speed, not like getting tired, how long would it take for the cheetah to run 35 miles? So again, I am going to set up two equivalent rates to each other using the funds method. This is a rate because we are not working with the same units. So in the first example, we were comparing two kinds of animals. In this case, we're comparing two totally different types of measurement. We're comparing a measurement of length, miles, to a measurement of time, seconds. So that's what makes it a rate problem. So if I use my funds acronym to help me set up, I am going to set up two equivalent fractions. So I'm going to put my fraction bar with my my two fraction bars with the equal sign in the middle. So I've set up my fractions. Now I have to determine my units. So my units are going to be miles and seconds. So again, it doesn't matter if I put miles as the numerator or miles as the denominator. I just have to make sure I'm consistent with both fractions that I'm setting up. So I'm just going to do miles over seconds. So anything that has to do with miles will go as my numerator. Anything that has to do with seconds is my denominator. So I've identified my units. Now I'm going to plug in the numbers. So they say a cheetah can run 10 miles in 320 seconds. So that 10 miles in 320 seconds is going to go on one rate, on one fraction, because that's the first relationship they give us. So that means 10 miles in 320 seconds. So I'm putting 10 over 320. And then the second relationship is I am looking at how long will it take a cheetah to run 35 miles? So they give me 35, they give me the other amount of miles, but I am trying to figure out how long. So in seconds, essentially, it takes the cheetah to run 35 miles. So I'm putting an X there because that is what I am solving for. How many seconds does it take the cheetah to run 35 miles? So now I have plugged in my numbers, and now I'm going to solve. I could try, like before, to look at the crossroads method to see, look at my numerators, look at my denominators, and see if there's a very obvious factor to get from 10 to 35. I know I'm multiplying, and I know I'm probably gonna have to multiply by some sort of like decimal, like it's not going to be a whole factor. So I could try to figure out what that is. However, I also have this other method of cross multiplication. So I'm going to use that method this time just to try something else. So cross multiplication means I am going to multiply the numerator and denominators diagonally across from each other. So I'm circling kind of what I'm going to be multiplying and set up that equation. So I have 10 times x, or 10x, is equal to 320 times 35. So if I go through and I simplify this equation, 320 times 35 is 11,200. So I have 10x equals 11,200. So if I solve for x, I am simply going to use the depot property. I'm going to divide both sides by 10. So I'm using that depot property, and 10 divided by 10 is just x, and 11,200 divided by 10 is just going to be 1,120. When we divide by 10, we can cancel out a 0 if we're looking at it like a fraction. So it's going to take the cheetah 1,120 seconds to run the 35 miles. Provided that the cheetah doesn't get tired or take any breaks. So I have now officially solved. So I use the cross multiplication method to solve for the amount of time it takes a cheetah to run this amount of miles. So the biggest hurdle is figuring out where your numbers go once you have the the fraction set up. That's why it's really important to make sure you identify where you're going to put your units and just make sure you stay consistent. I put miles as the numerator of both of my fractions, and I put seconds as the denominator, and I made sure that every relationship was on its own fraction. So 10 miles to 320 seconds and 35 miles to, the missing piece that I was trying to solve for. So go forth, try some more of these examples on your own, whether it's your homework or a mastery check, and have a great day.